now on Chapter 5, Lesson 4, Terminating and Repeating Decimals. Please turn to page 379. Before starting this lesson, I'm going to show you a cute cartoon. You may not understand this now, but you will soon. Whatever you do, don't talk to that guy. He'll go on forever. Pi is the loneliest number. This lesson is going to be a bit confusing because we have to talk about a lot of words. And words have meaning, each of them different. So kind of follow along as we go. Any number that is written as a fraction is called a rational number. Rational numbers can be written as either terminating decimals or repeating decimals. So let's think about a terminating decimal. What does the word terminate look like? You guessed it, a stop sign. That means the number stops. Looking at these, we have 0.33333 ... Doesn't look like it's stopping. And then we have 6.25. Well, let's look at 6.25. 6.25 can also be written as 6 1/4 or a quarter. It then can be written as a mixed number. 6 times 4 is 24 plus 1 is 25 over 4. Well, that looks like a fraction, and it looked like it stopped after the 5. You're right. Terminating decimal. Now, we have a repeating decimal. But repeating decimals, there's something that's very important about a repeating decimal to be rational. It must have a pattern. Does 0.33333 have a pattern? Looks like it does to me. Looks like those 3's are going on forever. So now let's talk about fractions and decimals real quick. Numbers can be expressed as fractions and decimals. Really? And be the same thing? Yes, they can. So in this case, I have to express 1/2 as a fraction. Well, that's 1/2. Did you know that the over sign is actually an operator? Let's blow it up and look to see what it looks like. What does that look like? You guessed it. All that is a division problem. So this is the divider. We're going to divide 1 by 2. When we do that, 2 goes into 1 0 times. Put your decimal. 2 goes into 10 5 times. Therefore, 1/2 is written as 0.5. Now we'll write 1/3. This is going to be a very important fraction for you. And at some point, I want you to start memorizing a few of the key fractions. This is one of them. 1/3 is 1/3 of the pi. It repeats on and on and on. 0.33 repeat. Turn the page. Now we're going to get into some complicated stuff. We're going to talk about rational numbers. Again, a rational number is any number that can be written as a fraction. Oh, but there's a rule. B, or the divisor, or dividend, cannot be 0. I want you to take your calculator and hit the ND button. Then I want you to put 3, arrow over, 0, arrow over. It should look like a fraction, 3 over 0. Now hit enter. What does it say? Error. You cannot divide by 0 ever. Okay, so back to the lesson. We know that rational numbers are fractions that can be written as either decimals or fractions. In this case, 0.8 is a decimal and 1/2 is a fraction. 5.2 repeat is a decimal but more importantly, it's a repeater, where this decimal 0.8 terminates. Now let's talk about our numbers real quickly. Rational numbers we just talked about can be expressed as fractions, integers, our negative numbers, 0, and positive numbers. They are whole in appearance, which means they have no remainder. Inside that, you have whole numbers. Whole numbers are 0, 1, 2, 3, ... Those are all the numbers you can count, including 0. Why? Because a donut has a hole. Now let's look at the fractions in the box. 3/10, you can say, is 0.3, and then you can throw some zeros after it. If I put 200 zeros after it, are those zeros really repeating? Are they worth anything? I don't think so. Therefore, we know that it is a terminating fraction because it stops. 4/5. Can we get that up to a multiple of 10? Well, if I multiply it by 2, I have 8/10. 8/10 can be written as 0.8. It also is a terminator. Now let's look at 5/6. When we do the math of 5/6, we get 0.8333 repeat. It does not terminate, therefore it is a repeater. It's still rational because it does have a pattern of repeating 3s, but does not stop. Bar notation, lastly. Anytime a number repeats, you put the bar over the numbers that are repeating. Okay, now we have to get to the hard part of the lesson. Oh no, Miss Morris, we have to divide? Yes, you have to divide. In today's problems, as you're working them at home, I expect to see a notebook piece of paper with all of these problems in the got it sections worked out. Yes, I will repeat that again. You have to work these problems out unless you can figure out the pattern. Do not, I repeat, do not use a calculator. So what we know in a fraction is that the numerator is on top and the denominator is on bottom. The denominator is outside the den. Down, denominator, don't go in the den. All right, let's all repeat it. Down denominator, don't go into den. Go tell your parents, down denominator, don't go into den. Don't go to Miss Smith and say, down denominator, don't go into den, because she's going to hit you on bad grammar. But that's okay. We're using it for a reason. It doesn't matter whether the denominator is bigger or smaller than the numerator. Down at the denominator, don't go into den. So when we work this problem, 5 goes in the den, 12 goes on the outside. When we look at that fraction, we know that it's not a complete whole anyway. So we know that the first digit has to be a 0 followed by a decimal. And then the math begins. If you look at the problem worked out, you'll notice that when we have a remainder of 8 and then add our first 0, that 12 times 6 is 72, and the 8 appears again. And then the 8 appears again. So at this point, we know that 0.416666 is going to repeat. We're going to put the bar notation over the 6 only. Be very careful. The bar notation only goes over the part that repeats. I'm sure you've now looked at the next page and realized that it's a got it section, and that you're going to have to work these fractions out. Do not use a calculator. Do pull out a piece of notebook paper. You cannot do the division of these problems in the little space provided. I will, however, help you by setting them up. 1/6. 6 is the denominator. Don't go into tree or den. 8/9. 9 is the denominator. don't go in the den. 2 11ths. 11 is the denominator. Don't go in the den. Now, I expect to see this sheet of paper when you come in tomorrow. All of these problems that require division, I want to see them worked out. Turn the video on pause, do the work, come back and check your answer. You should have gotten 0.166 repeat, 0.88 repeat, 0.1818 repeat. Notice that I would put a couple of the repeaters just so that you can see the pattern. Now, when we're talking about negative fractions as decimals, the problem is exactly the same as the previous problem, except for the last step is to take that negative and make sure it appears on your answer. Again, it's still a division problem. Lastly, when we have a mixed number, we can take the whole component out and then work with the fraction. In this case, we know we're going to start with -2. Then we have to determine what to do with the 2/3. Well, on the previous page, we learned that 1/3 was 0.33 repeat. Can you guess what 2/3 would be? All I have to do is multiply it by 2. 3 times 2 is 6. You guessed it. 2/3 is 6 repeat. So back to my problem. My answer would be -2.66 repeat. The problem's at the bottom. This one should be familiar because it's talking about money. The next one you're going to need to work out, as well as the following problem. Again, on F, remember that you have a whole component on it. Do the work, come back. Did you get these answers? D is -0.25. E is -0.8333 repeat. And F is -2.16, and the 6 is repeat. Turn the page. All right, now let's talk about the calculator. The problem 3/4 out of, okay, I'm going to turn this off for a second because I don't have the smart board. I'll come right back. Okay, we're back. Now that my smart board is working correct. 34 out of 44 shots. 34, oh, still not working. Let's try one more time. 34, must be the blue ink, divided by 44. Now, in this case, they used a calculator. When we entered into the calculator, you notice that the first 2 digits after the decimal are 77, and then we start seeing a pattern of 2727. So in this case, if I were to round it to the nearest thousand, it would be 0.77. Put my line, look over the fence. 7 is greater than 5. We have to round the 2 to a 3, and the answer that I would put on my answer sheet would be 0.773. Now, again, I want to caution you. In the guided practice, you must work these out the normal way on paper. You are not to use a calculator. So I'll draw my little calculator symbol, blah, 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 and then put my little red line in here. I do not expect to see any of you using a calculator on any of these division problems. Why? Because the more you divide, the better you become at it. Turn it off, get the guided practice done. When you're done, turn it on, check your answers. Okay, now that you've turned on the video, check your answers. And again, I expect when you come in tomorrow to see a piece of paper with these problems worked out. Remind me tomorrow to show you the secret. Yes, there is, oh, back to the blue doesn't work. There's a secret for 9s, 10s, and 11s. Once you know this secret, you'll be able to do those division problems without a piece of paper. See you tomorrow.